going to be in English, so I hope it's okay with everyone. First of all, thank you for having me, PyCon. I'm going to be delivering a very, very personal talk, very close to my heart, about how I learned what the fuck are embeddings. And it's going to be a software engineer's take on the topic. So I promise no fancy math, no formulas, maybe just one formula, but it's going to be super simple. So, first of all, hi, I'm Lisa. I'm of one baby, 3 cats, and one husband that desperately tries to keep up with us. I've been in tech for over 20 years, and 3 years ago, I left Elastic to start my freelancing and consulting business. Coincidentally, that happened exactly when ChatGPT was released, so pretty quickly, just a few months in, most of the projects that I was doing were AI related. So I started with doing chatbots and then became RAG, agents, MCP servers, GenAI powered pipelines, you name it, I've done it. About a year ago, I joined a consulting company called Big Data Boutique, and I became the GenAI lead of an entire team that does the same thing. So once again, everything I was doing in the past 3 years was GenAI related and in production. Now, the most important thing to know about me is that I am a builder. I build things with my hands. I do not have any computer science degree. I have a physics degree. I think that's completely unrelated and very old at this point. But my approach to building software is completely hands-on. I learn by doing, talking to people, watching talks, watching videos, playing around with things, breaking them, breaking production, waking up on Friday. But eventually my customers are usually pretty happy. You tell? You tell it? Cool. So, as I started building more and more of these projects, I started noticing a pattern emerge. And I was going to ask how many of you have heard of RAG, but I already know the answer. Everybody heard about it as of this point of this day. So I'm just going to assume that you have heard about it, but I'm still going to explain what the hell is going on. So you all know that RAGs are large language models, and as such, they are trained. They are trained on huge data sets, but once they are trained, they don't actually learn anything new. So if you remember about 2 years ago, if you asked ChatGPT something about something that happened last week, it would tell you politely, sorry, I don't know, I have no idea about that. So if, let's say, you wanted to build a chatbot for your company that has access to your company's private information, let's say user profiles, insurance policies, logs, then you would be responsible to provide that information to the LLM so it can work with it, right? It has no idea, hopefully, about your company's private information. So the architecture of RAG applications looks always kind of like this. So it has 2 parts. First of all, you take your documents. Let's say you're working with your insurance policies of all of the employees in your company. Then you pass them to something called an embedding model. And I've heard it being thrown around in a couple of the previous talks, but it's just there, hanging out, chilling. So you give your documents to the embedding model, and in return, it gives you vectors. Cool. You store those vectors in something called a vector store or a vector database for posterity. You just put them there, and the first part is done. The second part is where actually the magic happens. So a user wants to interact with your system. So they ask a question, or they they ask a question or provide a query, and then you do something, in my opinion, a bit strange. You take that question, you give it to the embedding model. It has to be the same embedding model, and it's just a fact. Like, this is how it's done, this is the architecture. You give it to the embedding model, it gives you a new vector, and then you use that vector to search the vector database, and then you hopefully, somehow, magically, if you've done everything correctly, you get the right documents for your question. So let's say I had a car accident and I need to know something about my insurance, and I asked like, hey, sorry, application, I had a car accident, what do I do now? This process will fetch from the database the right pieces of my insurance policy, and hopefully I'll get an answer. So I'll pack it with, with a prompt, send it to the LLM, and if everything is once again correct, I'll get my answer. But one thing kept bothering me as I was building more and more of these applications. What the fuck does this box do? What is this? Like, We're all used to LLMs doing what LLMs do, but this embedding model, I didn't really understand what it was doing. And I asked my colleagues, what was it doing? And all of them told me that this embedding model was capturing no other than the meaning of my insurance policies. And I'm like, what is the meaning of an insurance policy? How, like, do they have meaning? Like, I don't understand the meaning of my insurance policy. I will be glad to know that there is one. And how do you match documents with a question? Like, all of it was absolutely strange. And I felt like because I didn't have a computer science PhD, I couldn't understand this. Like, I wasn't equipped with understanding this question. But I still had faith that my existing software engineering experience and toolkit would be enough to at least have some basic understanding about what was going on. So at first, I zoomed in and trying not to fall off the stage. So at first I zoomed in and I probably was hungry because the first question that came to my mind was, I would like to eat a banana, please. And I gave it to the embedding model, and the model gave me no other than 1,500 numbers, approximately, more or less. And I was told confidently by everyone I knew that these 1,500 numbers accurately represented the fact that I wanted to eat a banana and that I was polite about it to our future AI overlords. And if I just store these 1,500 numbers in a vector database, then tomorrow someone would be able to ask and figure out that I wanted to eat a banana. Very curious, but absolutely not helpful to me understanding what was going on. So then I did what every good engineer has been doing for the past 20 years, and I Googled. I Googled like crazy, and then I Stack Overflowed, and then I Chat GPT'd. And here are some of the best definitions that Google has given me. So first of all, vector embeddings are vectors that represent real-world objects. Embeddings are also points that are semantically meaningful, and my personal favorite is that cosine similarity quantifies semantic relationships between points of data. Well, I hope it's all clear now. Thank you very much. Enjoy the rest of your day. Thank you. I yield the rest of my time. I mean, what the fuck? What the fuck does that even mean? Sorry, like, I know there have been a lot of talks here about this, but, like, what does this mean? Like, what do I do with this? It sounded to me like the internet was telling me, hey, girl, either trust the magic, just trust it, use it as a black box, or go get off your lazy ass and go get your PhD. But as I was processing all of this information, a mental image started to form. Everything was pointing me towards a space or a vector space. Now, I have a very limited human brain. I'm absolutely not good with visualizing 1,500 dimensional spaces, but I can kind of deal with 3D, sort of, kind of. And in the space, which I had absolutely no idea how it was created, how did it come into existence, there was a property. And this property was the two similar things, like this fact that I wanted to eat a banana and the fact that I wanted to eat an apple, those two things would be close together in the space. And if there was a different fact, like my red ball is on the floor, then it would be further away, I guess. But this just moved the problem elsewhere, right? How do I know what's close and what's far away? So I remember the cosine similarity from before. It sounds fancy, but it's just a trivial mathematical function and the only one in this presentation, I promise. Cosine is just a super trivial function that becomes 1 when two vectors are going in the same direction and becomes 0 when two things are perpendicular to each other. So I guess with cosine similarity, I mean, if two things are close, their cosine similarity is 1. And if they're different or unrelated, then it becomes 0. Okay. But this is all very theoretical. Way too theoretical for my liking. Like I told you, I'm an engineer. I want things to be concrete. I want to feel them with my hands to know how they work. So this is why I have come up with the test. The test was inspired by a card game that my daughter has. She has this game with cards and words and pictures. And she, before she's even 2, she can tell that, you know, a banana and an apple are one kind of thing and a cat and a dog are a different kind of thing, right? And if embedding models are so smart that they can understand the hidden meaning of my insurance policy, then they should be able to play this game, at least according to my imagination and theory. So what I did was I created a huge, huge set of words and sentences about everything I could think of. So I had animals, I had foods, I had furniture and clothing, I had verbs and adjectives and pieces of code and random gibberish and emojis. I embedded them with Cohere, which is my personal embedding model of choice. You can use any model, it will do just fine. And then I set out to explore and hopefully understand what the fuck are embeddings. So the first thing that I wanted to know, personally, was what is the closest thing to a banana? And what is the opposite of a banana? So my imagination was that the most similar thing to a banana would be, I don't know, a mango or a pineapple, and the opposite would be a steak or a shoe. But when I saw the results, I was surprised to find out that the most similar thing to a banana was, in fact, a gorilla. And the least similar thing to a banana was a Python function and a bunch of abstract concepts like blockchain. And at first I was puzzled. At first I was surprised. But then I remembered that embeddings are created or generated by an embedding model. And the embedding model was trained to do a very specific task. It was trained to learn associations or similar things in human language. And the fact that monkeys like bananas was actually stronger than its association with any kind of fruit. It wasn't playing at all the same game that my daughter was playing. It was learning associations in human language. Next, I tried to embed sentences because for me, embedding words, it felt kind of more, I don't know, trivial. Like it felt simpler. I could deal with it emotionally. But looking at meaning of sentences and paragraphs, that felt more difficult. So I took two sentences that were not in my original dataset. Lemons are yellow and grapes are purple. I embedded those sentences using the same technique. And then I looked up what was the most similar thing to each of them. The first result wasn't actually that surprising. The first one had grapes, the other one had lemons. So that's no surprise there. But the second one was tricky. The most similar second results to each of them was the fact that bananas are yellow. Why? So this is what everyone means when they say semantic meaning. Everyone keeps throwing that around, but semantic meaning means that you're not only looking at the keywords. You're not actually looking at the specific words that are used in each sentence. Embedding models are trained. They're machine learning models, and they are trained not only to look at the keywords, but the underlying ideas in each sentence. So all of these sentences are talking about fruit and their colors. So then it really makes sense that the embedding model has picked up this sentence as the second best match in my set. So once again, no magic here, no black box. It was just trained to recognize abstract concepts as something that is similar. And lastly, I wanted to see how the embedding model would handle something it hasn't never seen before, right? So I embedded the word banana, and the word banana landed me on a snake. Now, I have absolutely no idea why it landed me on a snake. My best guess is like banana sounds like anaconda. I don't know, but that was kind of random. But the second I added just 2 words of context to the sentence, I was able to snap back on and retrieve the hidden meaning from what I said, even though there was a typo. Now, at first, once again, it looked like a bit of magic. But then I realized that these models were designed, they were trained and designed to do this thing. They were trained to look at the context and recover meaning from a sentence, just like a person, if they heard a word they didn't know in a sentence, they could recover the meaning of what the word meant. So once again, no magic. It's just a model that was trained to do a very specific thing. It was trained to use the context to recover meaning. So, of course, I don't have internet. This is obvious. No, that's the wrong one. Ba, 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 ba. No video. That is unfortunate. Vamos a ver what other? Dum 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 dum. So I was going to say that I am like I said that I am a software engineer, and all of this is super theoretical, super cool examples. I like it. I need to connect to the internet, but I really wanted to see embeddings for myself. And the problem with seeing embeddings at is that, like I said, they're 1,500 dimensional spaces, and I think that none of us is really equipped with seeing that. So instead, I use something called UMAP, which is an algorithm that is capable of reducing dimensionality from 1,500 dimensions to just 3. And this is what I saw where I used it. So this is the embedding space. And on the left, you can see a bunch of this huge cloud. This huge cloud is actually consisted of objects. You can see different colors, color coding different types of things. So animals, foods, furniture, cars, whatever. And then there's this cool long tail extending away from this cluster. Along this tail, you see groups of verbs, of adjectives, of professions, things that are more abstract. And the further away you go from this cloud, things become more and more abstract. You have numbers, you have function words like and, or, then. You have random gibberish, pieces of code, go there as well. And for me, the coolest thing about it is it's like an X-ray or an ultrasound of what the embedding model has learned. And everything that you embed, everything, any sentence, any paragraph, fits somewhere there in this cloud. Before we finish, I noticed that some points were not ending up where I expected them to. And I want to share with you the curious case of the kiwi. When I thought of a kiwi, when I embedded the word kiwi, I was thinking about the fruit. But figures, it somehow landed in the animal space. I immediately remembered that there was an animal called kiwi, but my main question was how do I explain to the embedding model what I really meant? Because I meant the fruit. It definitely didn't understand me. So I decided to use when I just learned about context. I added a few additional sentences like a kiwi can fly or I ate a juicy kiwi. And immediately the embeddings went to the right places. So one of them ended up even deeper in the animal space. And the one where I ate a juicy kiwi, just because I don't know anyone who has ever eaten the kiwi, hopefully, that ended up in the vegetable section, the fruit and vegetable section. So with that all being said and done, with all of these fun examples and visualizations, what the fuck are embeddings? So embeddings are actually created by embedding models. And those are machine learning models that are trained on huge sets of language to do very, very specific things, right? They are trained to capture associations, not to do categorization. They capture associations and things that go together in language, like monkeys and bananas or bread and butter. They match semantic meaning. They don't only look at the keywords, they actually understand deeper concepts, deeper abstract concepts like fruit or colors, which are abstract things. They're also designed to rely on context. So they don't only look at the individual words, they actually look at paragraphs and sentences to actually understand what they mean. But in my opinion, the most important thing is that embeddings are becoming the backbone of AI and search applications. And this is because it's the first time in the internet's history, at least, that we're building interfaces that take free text instead of using drop-downs and buttons. And as such, we need to be able to understand human language really well. And even if you're not a computer science PhD, or you don't have your degree in machine learning, and you don't understand how these things were designed or built, because, I mean, companies use millions of dollars to train and design them. It doesn't mean that you can't use your existing software engineer toolkit to play with them, understand them, tinker around, and really develop an intuition about what they actually do. And when you develop that intuition, this intuition is going to help you not treat those things as black boxes or magic, but actually understand what they're good at, what they're bad at, and use them to build amazing software that is beneficial to everyone. Thank you.